reaction.
Welcome back. So in this video, we're going to continue predicting products, but this time we're going to look at different types of reactions, including combustion, decomposition, and synthesis, also known as a combination reaction. So the first type of reaction that we're going to look at are combustion reactions. And so combustion reactions are one of the most common reactions that you see happening every single day, because combustion reactions occur whenever anything burns. And so something that you see a lot is a fireplace. And so a fireplace is a really great example of a combustion reaction in real life. And so writing down the exact equation of what's going on when we look at a fireplace is a little bit difficult because wood is not really a pure substance. Each wood has different impurities in it, but let's just, for sake of explanation, we're just going to simplify because wood has a lot of glucose in it, so we're just going to pretend that the entire log is made out of glucose, even though this is really an oversimplification. So if we look at glucose is C6H12O6, so just some carbon, hydrogen, and oxygen, which is sugar. And so we call this a hydrocarbon, and hydrocarbons are mainly what you're going to find as a reactant in a combustion reaction. And then the only other reactant that you have to add to it is oxygen, and then that is going to combust. So combust means that it's going to rearrange into carbon dioxide and water as vapor because it's very hot. And so this is called complete combustion. So in a complete combustion, it appears as though whatever you have that used to be there, it seems to disappear because it all leaves in the form of gas as either carbon dioxide or water vapor. But as we can all say, when we burn wood or when we burn other things like that, obviously all combustion is not complete because a lot of times you have this black ashy kind of stuff that contains a lot of carbon and stuff like that. So there are indeed two types of combustion reactions, and there's the complete combustion, which we showed before, which is the simplest, but then there is also incomplete combustion, where you may have carbon monoxide or some sort of carbon left over if it does not combust completely. So here's an example of an incomplete combustion. So what we have here is the incomplete combustion of propane, C3H8. So you've got 2 C3H8 plus 7O2 yields 6 CO, which is carbon monoxide, and 8 H2O, water vapor. And so as you can see, this did not go to completion because you did not produce CO2 and H2O, you produced carbon monoxide and H2O. However, in AP chemistry and in a lot of your introductory level chemistry classes, you're really only going to deal with complete combustion because it's very difficult to predict exactly the products of a incomplete combustion, so you're really only going to have to predict the products of a complete combustion. Okay, so now we're going to take a look at the synthesis reaction. So to review, in the past we looked at the double replacement reaction when we had two compounds reacting. We looked at single replacement reactions when we had a compound and one element, usually a metal, reacting. And we looked at combustion reactions when we had a hydrocarbon and the oxygen gas in the air reacting. But what we haven't looked at is when we just have two elements that are going to react or combine, and that is the synthesis or combination reaction. So, for example, let's look at the synthesis of water. We know that our product is going to be water, which is H2O. So all we're going to do is take the individual components that are needed to make up water, which are hydrogen and oxygen, and we're going to come up with the equation H2 plus O2 yields H2O, which is not balanced. But now you may be wondering why it's not just H plus O yields H2O. And that's a good question. Hydrogen and oxygen are both diatomic elements, which means that naturally occurring, they're never just going to be on their own. They're always going to bond to themselves. So let's say we are given two reactants and asked to predict their products. How do we do that? So let's say, for example, our reactants are potassium and chlorine. So we've got K and Cl2. Again, Cl2 is diatomic, so we know that it's going to be Cl2, not just Cl. And really, all we have to do is write, K plus Cl is going to yield KCl, but we're going to have to make sure that we balance that. In this case, it's not going to require any subscripts because K and Cl have a charge of plus and minus 1, so they're going to balance each other out. So really, all you need to do to predict those products is put your individual parts, connect them together, and cross your charges so that your product is neutral. Alright, so the next type of reaction we're going to look at is decomposition reactions, which once you know what a synthesis reaction is, a decomposition reaction is super easy to understand because it's really just the reverse reaction. So if the synthesis reactions were A plus B yields AB, decomposition reactions are just AB yields A plus B. So let's look at an example. So we are going to try to predict the products of the decomposition of potassium chloride. Does this look familiar? And so, you've got KCl, which is potassium chloride, and that's just going to break up into its elements. And you're again going to check for those diatomic elements, like chlorine in this case, that are going to have the two. But it's as simple as that. You're just going to break it apart into its elements. That is all a decomposition reaction is. Okay, so let's review. First, we looked at combustion reactions, and we learned that the reactants are always going to be a hydrocarbon or some other combustible material and oxygen gas. And then the products of a complete combustion are going to be CO2 and H2O, or carbon dioxide and water vapor, both as gases. But in an incomplete combustion, the reactants are the same, but the products may be carbon monoxide or maybe some carbon. But usually we're going to assume that it is a complete combustion if you're being asked to predict the products. Then we looked at a synthesis reaction, which another word for synthesis reaction is just combination reaction. And we saw that we're just going to take the two reactants and combine them, and we're going to make sure to cross the charges so that the charge of the product is neutral. And that's really all that a synthesis reaction is. Then we looked at decomposition reactions, which are the reverse, in a way, of the synthesis reactions. And we know that to predict the products of those, we just have to split up the compound in the reactants. We're going to split it up into its elements, and we're going to check for the Hofbrinkel elements, which are the diatomic elements, because those are going to have a subscript of 2 because it bonds to itself. And that's all we have to do. Very simple. So thanks for watching. I hope you learned a lot about how to predict products of chemical reactions.